New series on integration for IB students. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to understand how do we integrate e to the power minus x times sine 3x dx. Well, this just reminds us of integration by parts, and that should be the best way of integrating. So we'll do so. Meanwhile, let me first thank all my viewers and subscribers for watching my videos and posting excellent questions like this one, which comes from a student of mine. In case you want to learn from me, you can send an email on globalmathinstitute@gmail.com. Our students are right there on the top. Now, before doing the integration, let's remind ourselves what is this integration by parts and how are we going to apply it? So on the side, let me rewrite that if you have integral, let's say one function u times dv, then you could rewrite this as equal to uv minus integral of v du. Integration is still to be done, but we could select the function so that integral is simpler this time. Now, how do we really split and write? Well, there is a way of priorities to write which one as u and which one as dv. Latte is the short form, which you can see in my videos. Link is being provided. Here we have e to the power of minus x and sine 3x. Both are under the same category. You will notice that one function repeats the derivative after one more derivative. Sine 3x, for example, will be cos 3x will be sine 3x with a sign change. So we might just run into multiple application of integration by parts, and that is what we learn in this particular case. Now, let us see how to split this into u and v. So we're going to write u as e to the power of minus x and dv as sine of 3x dx. Derivative du will give me minus e to the power of minus x dx, and integral of dv will give me v equals to sine 3x integral will be minus cos 3x over 3, right? Now, using the strategy which I use in my videos, uv is this product, correct? And the product v du is this way, correct? So let's rewrite the integral as uv, which is, you can see, minus u is e to the power of minus x. So minus cos 3x, I wrote minus first, cos 3x over 3. Minus integral of v, which is minus cos 3x, so I'm making this as positive, cos 3x over 3. Du will be e to the power of minus e to the power of, let's say, minus e to the power of minus x dx. Now you see, in the integral, we have again cos 3x by 3 minus e to the power of minus x. Let's first rewrite this. We get minus e to the power of minus x cos 3x by 3 minus integral of 1/3 of cos 3x, right? We can take 1/3 here, which is a constant, cos 3x e to the power of minus x dx. So practically the situation is almost the same. Now to take care of this integral with cos 3x, we'll again apply integration by parts. And so once again, we are going to use u v minus integral of v du, right? So let's take it, this integral part on the next page. So now we are going to integrate e to the power of minus x cos 3x dx, right? Again, applying uv. So, once again, u will be equals to e to the power minus x dv as cos 3x. So, we have du minus e to the power minus x, and v after integration will give us sine 3x over 3. And therefore, we can now rewrite the integral of e to the power minus x cos 3x as uv. So let's multiply u and v, and then v du, right? So uv gives us e to the power minus x sine 3x over 3 minus v into u, which is sine 3x over 3. Du is minus, I forgot to write dx here. Minus will make this as plus e to the power of minus x dx integral. Do you see that? So what we get here is the part which we were looking into. Do you see that? Same integral. So if I say that this integral is I, then this integral is also related to that. Perfect? Correct? So now, instead of all this, we could have written this as e to the power of minus x, one third, right? Sine 3x plus one third of I. Correct? Now, this can be combined with what we had earlier, right? So we got the integral of this part. So that is how we have related an integral with another integral. And now we have our solution. You get the whole idea, right? So kind of we reduced it to a simpler form. So there we go, right? So we can now rewrite the whole thing as we'll do it on a fresh page. So the whole integral can now be written as equal to e to the power of minus x cos 3x over 3, right? That is the uv part which we got, right? Minus one third of integral of e to the power minus x sine 3x over 3, right? Plus one third of the same integral, which is I. You get the idea. So I, this integral, if I say is I, is equal to all this, correct? Now, we can bring it to the right hand side and simplify our expression, right? So if I open this bracket, I get I equals to e to the power of minus x, or let's multiply by 9 on both the sides, right? If I multiply by 9 on both sides, then I get 9I equals to 3 times e to the power of minus x cos 3x minus. So these 3's, they get cancelled with 9, and we get minus e to the power of minus x sine 3x plus, and minus becomes minus I, correct? Now bringing this I to the left hand side, we get 10I equal to 3 e to the power of minus x cos 3x minus e to the power of minus x sine 3x. So now we can get the final answer that the integral is equal to 3 over 10 e to the power minus x cos 3x minus 1 over 10 e to the power of minus x sine 3x. right? And definitely we'll write C for a constant, which will always be there. So I hope that makes sense. And this is how we are going to solve this particular problem by applying integration by parts twice. Hope that makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.